My name is Kate Timms, and today I'm going to be talking to you about Izon Science's nanoparticle measuring instrument, the Exoid. The Exoid uses Tunable Resistive Pulse Sensing, or TRPS, to measure the concentration, size, and zeta potential of particles, such as extracellular vesicles, lipid nanoparticles, or even whole bacteria. For an overview of how TRPS works, you can watch this video, which will talk you through the theory of TRPS and give you a look at the Exoid. Briefly though, TRPS works by stretching a nanopore to the optimal size for the particle mixture that you are measuring and running an electrical current through it. Then, particles pass through the nanopore one by one, briefly blocking the electrical current. The size of the resulting blockade is directly proportional to the size of the particle, giving you an accurate approach to particle sizing. Size measurements are calibrated to a known standard at the start of every run, ensuring that accuracy is maintained. The duration of the blockade is directly proportional to the zeta potential of the particle, and concentration is determined by the blockade rate. Now that you know how it works, you might be wondering why you might want to use the Exoid above competing instruments using different technologies. Here are 4 data-driven reasons why the Exoid should be your go-to instrument for particle analysis. The first and most important reason is accuracy. Here the Exoid massively outperforms nanoparticle tracking analysis, NTA, and multi-angle dynamic light scattering, MADLS. To illustrate this, here we have a quadrumodal sample containing 4 different groups of particles, each with different sizes. As you can see, when a quadrumodal sample is measured using TRPS, all 4 populations are easily and accurately identified, with each population being distinct from every other population. NTA, however, only manages to identify 3 of the populations, missing the largest population entirely. This fits with a comparative study by Akers et al., who showed that NTA, but not TRPS, is biased against particles larger than 150 nanometers. In addition to missing largest particle populations, NTA also failed to adequately distinguish between the populations it did identify, falsely showing a large degree of overlap between the size of these populations. MADLS performed even worse, showing a single broad peak, which is clearly weighted towards the smaller particles. As such, all information on particle populations is lost with MADLS. These vague and inaccurate alternatives to TRPS are just not good enough if you want accurate particle analysis. In using these technologies, a huge amount of data is simply not captured. Having the ability to identify multiple populations within your data is potentially hugely important. These subpopulations could reflect different subtypes of extracellular vesicles, loaded or non-loaded drug vectors, or even aggregates in your particles. Without this knowledge, important information about your particles is lost, meaning that you could miss what may be the most important thing about your particles. The discoveries lost to inaccuracy could be monumental. The question you have to ask yourself is whether you're willing to take the risk. The second reason that we believe that the Exoid is head and shoulders above the rest is the Exoid's ability to not only measure single particles, but to simultaneously measure size and zeta potential for every particle that passes through the nanopore. MADLS does not measure individual particles at all, and whilst NTA does track individual particles, it tends to overestimate particle concentration and is limited by the uncertainty in the Brownian motion calculations on which it is based. And while some instruments can separately measure size and zeta potential using different methodologies, they cannot simultaneously do both, like the Exoid can. This makes the Exoid the only instrument currently able to give you size and zeta potential information on the same individual particles. This allows you to identify populations in your data which are separated by either size or zeta potential, or both. As you can see here, whilst the blue and purple populations overlap in terms of size, they have very different zeta potentials, which significantly differ from each other, and from the population shown in pink. This has been shown in the literature too, with nucleic acid loading onto particles shown to be visible as a change in blockade duration, and therefore zeta potential. This brings us to the third reason why the Exoid should be your number 1 choice. With the Exoid, you can access your sample easily. Some researchers have used this to their advantage by loading molecules of interest to their nanoparticles and seeing how the zeta potential is directly affected. As you can see here, this has successfully been achieved to visualize DNA loading onto nanoparticles, showing a rapid change in zeta potential as the negatively charged DNA binds to the particles. This can be used to assay loading efficiency and time to load, along with examining particle aggregation. Finally, we believe that the Exoid is a sound investment due to its immense tunability. With the ability to measure from 40 nanometers all the way up to 11.3 micrometers using different sized nanopores, the Exoid can measure a huge range of particles, from extracellular vesicles and lipid nanoparticles at the small end, all the way up to whole zoospores at the large end. This means that no matter where your research takes you, within the range of 40 nanometers to 11.3 micrometers, you can be confident that the Exoid will be there to help you analyze your samples. This tunability is especially important if you do not know the size of your particles. As long as you can be reasonably certain that they fall within the range of your nanopore, for example, between 50 nanometers and 330 nanometers for the MP100, you can dive in and start taking measurements to find out. So, if you're after high-resolution nanoparticle measurements, the Exoid has your back. Its high degree of accuracy and ability to measure single particles gives you the data you need to truly understand your samples. This is something that you just cannot get with NTA or MADLS. True, these technologies may be technically easier to use, but at what cost? Here at Izon Science, we are not prepared to compromise on accuracy, even if that makes the Exoid require a little bit more time and patience to master. That is the trade-off for such a massive jump in accuracy and resolution. It's not unlike electron microscopy being more difficult to learn than looking down a light microscope. More challenging, yes, but also worth it. Get in touch today at izon.com to talk to us about how an Exoid could revolutionize your research on nanomedicine developments.